Hey guys, welcome back to the lesson that we started in class today. So we have been finding the zeros of polynomial functions, and we remember our fundamental theorem of algebra from last night's video told us that the degree of a function tells us how many total zeros it has. And the zeros can be real or non-real, and they can be rational or irrational. So let's get started with letter E. If I want to find the zeros of this function, I first need to set it equal to 0. So instead of p of x, I'm going to write 0 equals x to the fourth plus 3x cubed minus 4x squared minus 12x. And ideally, when we are faced with a polynomial equation, we would like to factor it. So let's ask ourselves, is there a greatest common factor I could take out of each of these factors? And because they each have an x in them, I can factor out an x out front. So I'm going to start with that. So x parentheses x cubed plus 3x squared minus 4x minus 12. Okay, so I actually have one factor already. Now let's look at what's left in the parentheses and see if we can factor this. This is a cubic with 4 terms. Remember, when we have 4 terms, we always try to see if we can factor by grouping. So I'm going to split the group after 3x squared and see what I can do. I will write 0 equals x and put big parentheses since I'm going to have some parentheses inside here. I can take x squared out of both x cubed and 3x squared, and I will have left over x plus 3. Then I have negative 4x minus 12. I can take a negative 4 out of both of those, and I have left x plus 3. So sure enough, grouping worked because my common factor is x plus 3. So let's bring that out front. So we have x, and then we have x plus 3, and then we have x squared minus 4. And we can keep factoring that. That is a difference of squares. So we have x times x plus 3 times x plus 2 times x minus 2. And this is completely factored. I have 4 solutions. I have x equals 0, x equals negative 3, x equals negative 2, and x equals positive 2, which should make sense because our degree is 4. These are all real, and they're actually all rational. Okay, let's move on to the last example. P of x equals x to the fourth minus 16. And let's go ahead and set that equal to 0 since we are finding the zeros. And we ask ourselves, can we factor this one? And we can factor this one if we think of it in terms of a quadratic. So I could rewrite this as, in parentheses, x squared being squared minus 16. And you can use your u substitution if you would like. Let u equal x squared. So I'm going to rewrite this as u squared minus 16, which is now a difference of squares, which I can factor to u plus 4 times u minus 4. Now that I've factored it, it's time to put my actual value for u back in, which is x squared. So 0 equals x squared plus 4 times x squared minus 4. And then we see if we can continue factoring. We cannot factor x squared plus 4, but we can factor x squared minus 4 because that's a difference of squares. So 0 equals x squared plus 4 times x plus 2 times x minus 2. Finally, we set each of these factors equal to 0 and solve to find the zeros. X squared plus 4 equals 0. Subtract 4, so x squared equals negative 4, and then take the square root. I'm taking the square root of a negative number, so we know our solutions will be imaginary. That'll be x equals plus or minus. Since 4 is a perfect square, I'm just going to have 2i. So there are 2 non-real solutions. Those are non-real. And then my 2 factors over here give me x equals negative 2 and x equals positive 2. So those are two real solutions. For a total of 4 solutions, let's look back at our original problem. It was degree 4, so that makes sense by the fundamental theorem of algebra.